Hello everybody, hope you're doing well. My name is Mahmoud Kiosari and today we are going to work on the next subject, which is about the polynomial. If you can remember from the previous sections, we were talking mostly about a quadratic equation, which is one form of polynomial that has a degree of 2. By the way, degree is some kind of definition. We will talk about it, don't worry. So today we are going to try to expand it, and we are going to see that what would happen if we do have some kind of bigger numbers, for example, x to the power 3, x to the power 4, or maybe more than that, and what would happen actually to the graphing and to the function itself based on our knowledge with the intersection with the x-axis, which is something we know as root, and with the intersection with the y-axis, which we know something as f of 0. We are trying to see that what would happen as a detective. So without further ado, let's just talk about it. So today we would like to talk about this section, which is about the cracking the code of some kind of the polynomials itself. So we would like to see as a detective had to sketch every function that we do have around ourselves. So the very first thing that we have to talk about is the definition of polynomial itself. Wherever you have the some number, some kind of variable, x to the power 1, 2, 3, doesn't matter. Wherever you have something like that, and beside of that, some kind of other numbers, we just call it as a polynomial. So polynomial at this point, it has different kind of section, or it has different kind of definition. The very first important part is about the degree. What is degree? As you can see over here, degree means the largest power of x. For instance, if I do have x to the power 2 plus blah, my degree would be 2. If I do have x to the power 3, my degree would be 3, so on and so forth. So this one tells us the fundamental family that the polynomial belongs to. So as I just told you, for instance, when we do have x to the power 2 plus 2x plus 1, we know for a fact that this is a quadratic kind of family that is related to polynomial. If we do have x to the power 3, it's a cubic, x to the power 4, 5, and etc. Another important thing would be about some kind of the leading term. The whole term that is going to contain our some kind of our variable with the highest number, and also another number beside of that which is considered as a coefficient is considered as a leading term. We are going to use that because this entire term with the highest power is going to give us some clue about how actually the function is. The function is the like quadratic equation is going to be on the top. If you guys remember from the previous video, we did talk about it. For instance, if a number beside x to the power 2 was positive, it means that it opens up. If it was negative, it opens down. Based on the number a, is bigger than 1, is going to stretch, and if that number would be between 0 and 1, the absolute value of that one, it would be some kind of compressed. Another important thing that inside this one is about the leading coefficient that I told you is going to be the first important part of this family itself. So this is going to be the leading coefficients, and this number is going to help us in order to understand the whole behavior of our polynomial, and also its sign is important. We will see that in the future why. For instance, let's see a couple of examples. The very first example, I do have 2x to the power 4, I do have negative 3x to the power 2, and I do have 7. So at this point, I'm looking for the highest number in the power itself while it belongs to x. So I do have power 4 and I do have power 2. Since the 4 is the biggest, I would consider that. So the degree would be 4. Another thing that I have to know is about the leading term. So 2x to the power 4 is going to be my leading term, and the leading coefficient is 2. So right now I'm not sure and I don't know anything about it, how it would function in the diagram itself, but we will talk about it. Another one would be about negative 5x to the power 3 plus x minus 1. So at this point, I do have 3 as my degree, I do have negative 5 as a leading coefficient, and I do have negative 5x to the power 3 as the leading term itself. So let's talk about the leading coefficient, because this is the most important part of the family. Why is that? Because rather than just knowing the degree itself, is it odd or even, this leading factor or some kind of leading coefficient is going to help me to have some kind of clue about the whole idea or about the whole function. Yet in details part needs to have some kind of in detail investigation. But right now I do have a total idea that what's going on inside my function or inside my polynomial. Let's start. So from the very first one, if I do have a condition that my degree is even, by the way, again, the degree is the power of x. If that one is even, and if I do have the positive coefficient, again, it doesn't matter if that number is, the absolute value of that number is bigger than 1 or it's between 0 and 1. Right now, we don't care about that. If that number is bigger than 0, I know for a fact both ends points up. It means that I would start from the negative infinite to positive infinite. Both of them lead up. See, this is the quadratic equation, or this one, 2x to the 4. X to the power 4 is even, and 2 is the coefficient, and it's positive, so I know for a fact both end leads up. What would happen if I do have even degree and I do have the negative coefficient? It means that something like this. So at this point, just like the quadratic equation, both sides goes down, so both ends goes down. So I do have something like this. We will talk about these curves and why that happens, but let's just imagine that we do have something like this. Another some kind of condition would happen if I do have odd degree, for example, the power 3x to the power 5, and I do have positive coefficient. So at this point, I do have left goes down and right end goes some kind of ends up. Yx to the power 3, if you guys remember, was one of the parenting function, and the scenario related to that was exactly like this. So I can say not exactly like this, because in that parenting function we only have x to the power 3, but right now we do have another term beside. We just get the whole idea, because the number with the one that has the highest degree is going to be the one that actually we care about. So at this point I do have x to the power 3 because the number or the leading coefficient is positive, and also the degree is going to be odd. I do have 1 point goes down, 1 point goes up. And what would happen on another side? If I do have odd degree and negative coefficient, everything is going to be vice versa. It means that the left end goes up and the right goes down. At this point, we can have some kind of idea what is happening inside the function itself. Another important factor or definition related to polynomial would be about the zero, or we know it as root, and multiplicity. So we will talk about it right now, and we would see what are those actually. So the very first thing that we have to know, or at least we knew before, is a zero. So what is the zero or root? If you remember, for example, about a quadratic equation, the zero was actually x, or number that if we put it inside the f of x itself, our final answer or the whole f of x is going to be 0. Or function, or some kind of graphing wise, if we some kind of draw that function, it would be upside down, it could be anything. The intersection with f of x and x-axis is going to be considered as 0. So based on the degree, we can see that how many zeros that we have, and we will see that in the future. But again, the definition is 0r, which we know it as r, is any number where the function value is going to be 0. For instance, p of r is going to be 0, f of x is going to be 0. These are the points where the graph crosses or touches the x-axis. So again, as you can see over here, for instance, I do have something like this. And just despite of the fact that we do have different kind of degrees, but power of 1 and power of 3, I do have 1 as one of the roots, and I do have -2 as the roots. It means that for sure, if I use 1 inside this p of 1, and if I use p of -2, my final answer is going to be 0. Another thing that I have to know is about the multiplicity. What is some kind of multiplicity? It means that if a polynomial has a factor of x minus r. So again, as we all know, the factor, it means that you can define the whole idea, or instead of just having only a standard form like the one that we have in our some kind of quadratic equation, we can have another form. We can have 2 terms, or maybe more than 2 terms, multiplied by each other, and we call it as just a factor. So if a polynomial has a factor of x minus r raised to a power of k, then r is a 0. It's not only going to be 0, which we know it from before, with multiplicity of k. So it means that k is acting as a power, r is acting as a 0, and it's just the name as that. For instance, at this point, when I do have x minus 1 to the power 3, means that the root is 1, but the multiplicity is 3. At this point, the root is -2, but the multiplicity is going to be 1, so on and so forth. So what is exactly multiplicity tells us, and why we do need that? Because multiplicity is some kind of the evidence that reveals the graph's precise behavior at a 0. It answers 2 questions. Does the graph is going to cross, or only going to touch and turn? And how flat is the graph at that point? If you guys remember, let me remind you with the quadratic equation. So if you remember from this part, at this point, I do have x to the power 2, but it does have 2 intersections with x. So for sure, I know I do have 2 roots. If I do have this one, or maybe it would be better a little bit precise, if I do have this one, I'm touching my some kind of x-axis. So I only have one root. By knowing about the multiplicity and also the roots, I can somehow define my condition. That is going to be this one, or it's going to be something like this, so on and so forth. So another example over here, as you can see, I do have two roots, -4, and I do have 3. -4 with the multiplicity of 2, and 3 with the multiplicity of 4 itself. So right now we have to analyze how this multiplicity is going to shape the whole graph itself. So if you guys remember, if we do have some kind of odd multiplicity or somehow leading us to a fact that we are going to have odd power or odd degree. So at this point, if I do have odd multiplicity like 1, 3, and 5, for instance, x minus 1 to the power of 1, x minus 1 to the power of 3, and so on and so forth, it means that the graph for sure is going to cross the x-axis. The very classic formula of it, the very classic example is x minus 1. So I do have yx minus 1, again, is going to be to the power of 1. 1 is an odd number, so I can say I do have x minus 1 to the power of 1 as the multiplicity of 1. So for sure, I do have a point that is going to touch the x-axis. So we know that is the root is going to be 1. So after that, multiplicity of 1 is going to cross the line straight on, just a linear itself. What would happen if I do have 3? So at this point, I do have x minus 1 to the power of 3. Right now, it seems that somehow it's touching, but still that we do have some kind of interception with the x-axis. Why? Because it is increasing at this point, reaching to the 0, and again increasing at that point. So at this part, we can say it's going to cross, but it flattens out into some kind of S shape at the 0 itself. So by knowing the multiplicity, we know for a fact that I'm going to some kind of have the interception with x, and if I do have some kind of exceptional scenarios, I can have some idea what is going on exactly rather than being interception. So another thing that I can know is what would happen if I do have even numbers. So if I do have the multiplicity of 2, by the way, multiplicity of 1, 2, 3, and 4 are the ones that actually we care about. Most of the time we work on that, rather than everything bigger than that one would be a little bit advanced. So if I do have the multiplicity of 2, it means that it's going to touch and turn like a parabola, like the one that we were talking about. For instance, if I do have x plus 2 to the power 2, we can see that this guy is going to increase, and after that this guy is going to decrease, and that's going to increase. So what do I have? I do have the absolute minimum, if you remember from the last part. So x plus 2 to the power 2, it means that I do have -2 as my root with the multiplicity of 2. I know for a fact that at -2 they're going to touch, and after that they're going to change its behavior. So what would happen if I do have x plus 2 to the power 4? You can see that somehow the idea is the same because still the root is 4, but this guy is a little bit flattened on the -2 side. Unlike this guy is just like a normal curve, this guy is a little bit flattened. So we can say the multiplicity of 2 is going to give me a normal U shape, but the multiplicity of 4 is going to touch and turns, but it's going to be even flatter at that specific point itself. So let's talk about an example. Imagine that I do have my f of x is something like this. I do have -2 times x plus 1 to the power 2. I do have x minus 2, and after that I do have it as x minus 4 itself. Let's see what would happen at this kind of question. So for this part, first of all, let's just find the roots with related to some kind of there's multiplicity. So I do have -1 with the power of 2. I do have 2 with the power of 1, and I do have 4 with the power of 1. So I just found the roots and multiplicity, but right now I do have the combination of all of these terms. So it means that the second thing that I have to do, I have to find a degree. Why I'm telling you that we have to find a degree? Because if you remember from the very first slide, I told you that if I do have the degree and if I do have the leading coefficients, somehow it gives me an idea that what is happening. Then, based on the root and multiplicity, I can decide that what is happening inside the function itself. So right now, my job, the very first part, is to find out some kind of the leading ends. Are they going to both is going to both down, both up, one down, one up? I have to know what's going on over here. So if you just look at this one, and if you try to find a degree by this point, first of all, look at each term. So the power of this guy, you already know about times x plus 1, it would be x to the power 2. So I do have the degree of 2 for only this one. I do have the degree of 1 for this one because the maximum power of x is 1, and I do have the degree of this one for this one. And total, by adding all of these guys, I can find my total degree, which is 4. So I know for a fact that the biggest x, if I do all of the multiplication, I can find it, that the biggest x over here is going to be what? It would be x to the power 4. What is the some kind of the leading coefficient? The leading coefficient is negative 2. So I do have my even degree and I do have the negative coefficient. It means that both ends must point down, and this is going to be something like this. So right now, or at the beginning, I don't have any idea what is happening inside of that, right? I don't know what is going on, so I'm just considered as a black box, and I'm saying that both of these ones are going to be down. So right now, by knowing the roots and by knowing their behavior, I can decide that actually what is happening over here. Let's just look at it from the beginning. I do have x plus 1 to the power of 2, so this guy is going to be considered as negative 1 with the multiplicity of 2. So this one is going to touch and turn, just like y is x to the power of 2. It's going to touch and turn. Whatever some kind of behavior that it had is going to have the complete opposite on the other side. So since I'm going to start from here, and this guy is the very first thing that I see, so I know for a fact that negative 1 would be touching part, and after that, when I'm increasing, I'm going to decreasing as well. So another thing that I can find from here is about x to the 2 and x to the 4. It means that at this point I do have some kind of crossing, right? Because this multiplicity is 1, so I do have this point and I do have this one. Maybe some of you would ask, right now what is happening over here? I believe you all know how I can find this guy by just putting my x equals to 0, because obviously when we are talking about the y-axis, it's x is equal to 0. By finding a y, I do have another clue that is going to help me in order to draw this kind of functions. At some point, it would be a little bit confusing for you right now, because you would tell that, for instance, for the right side, we do have intersection. How we can understand that it's going to be, the shape is going to be like that. So by doing some kind of practice and by working on it and by see different kind of example, you can completely understand what is going on. But the main and important part of this section was knowing about the both ends, and after that understanding the multiplicity, what would happen with some kind of touching and some kind of changing in behavior, and also the x-interception itself. So after that part, we do have another section which I can say is an important section. So at this point, we are trying to see some kind of long polynomial divisions. So what does that mean? Imagine that I do have a point like this, and after that I would like to give some ideas from the function and drawing itself. Unlike the last part that we had term by term or by factor, at this point I don't have that kind of clue what is happening over here. So right now I have to find some roots. I have to see that how I can actually divide my whole some kind of polynomial function into small chunk by chunk, and after that I can decide what's going on. So it means that the theory beside this one, behind all of this story, is that when to use this tool. First of all, when we have to use this tool, as I just told you, when dividing a polynomial, for example p of x, by another one, just d of x of degree of 1. Remember, the one that we are going to divide by that should be degree of 1 or higher, but at this specific point, we're just going to talk about the degree of 1. This is essential for finding the factor. As I just told you, factors means roots, means multiplicity, and if I do have any remainder, I'm going to use that. So our goal is to write down the px, whatever is that, into form of dx times qx plus rx, where qx is going to be our quotient, and rx is going to be the remainder itself, and obviously its degree is going to be less than the degree of dx itself. So why again we are doing that? Because again, not all of those questions around us is going to be just by factors. Sometimes it's going to be combination of all of them. Sometimes it's going to be combination of all of them plus some kind of remainder. Everything related to that is going to help me in order to draw the function or the graphing that I would like. And at this point, we're going to help you with simple examples. Again, if we are going to talk about more advanced things, it would be a very advanced algebra. Right now, we are talking about the things that actually is going to help us, or very common conditions that you can use in order to solve some kind of your questions in an exam or any other kind of work that you have. So let's see what's going on. There's some kind of first step that we have to do when we are dealing with long polynomial functions like this one is, first of all, is the divide. It means that the leading term of the dividend by the leading term of the divisor itself, right? After that, we have to multiply the entire divisor by the results. You have to subtract and you have to repeat the whole process. It's just like the way that we use to do the division. And this means that sometimes you have to 12 divided by 2, it's just 6. And sometimes you have 13 divided by 2. It would be 2 multiplied by 6 plus 1. The whole process, the whole steps that you see over here is just like the exact same thing that we had before. But at this point, we are going to deal with terms. We are going to work with a couple of some kind of complicated terms that are not going to at the end give me one final number. It is going to give me terms. I know it could be a little bit confusing right now, but let me just try to talk about one example and you can completely understand. Imagine that I do have this condition and I give you a question and say that there's a 2x to the power 3 plus 3x to the power 2 subtracted 5x plus 1 as a long polynomial, and I would like you to divide that one by x plus 2. So obviously you would just write it down like this and divide it by 2 itself. So let's see what is happening inside. So 2x to the power 3 plus 3x to the power 2 subtracted by 5x plus 1. First of all, I'm going to look at this one and I'm going to compare this guy with this one and see what can I do in order to get rid of 2x to the power 3. What is the term that if I multiply by x plus 2, I'm going to at least losing this term alongside with other kind of things. So the very first thing that comes to your mind is that I can divide 2x to the power 3 by x, which is going to consider this term. I don't like this one. First of all, let's talk about this. So I do have 2x to the power 2. I know for a fact that if I can use the 2x2, at least I can get rid of this guy. So I'm going to say that the first part of the quotient is going to be 2x to the power 2. 2x to the power 2 times x is going to 2x3. 2x to the power 2 times 2 is going to be 4x2. And also I know I have to subtract it from the whole idea. So 2x plus 3x to the power 2 subtracted by whole thing. These two guys are going to cancel out each other. Then I do have negative x2, and obviously I have to move the next part to the down or to the bottom, which is going to be my third step. So after that, I have to find a way in order to get rid of negative x2. It means that what is the term that if I subtract it from negative x itself, I do have 0. So obviously this term is going to be negative x2 itself. So my job over here, what is to convert this x guy to negative x2. Obviously negative x is going to be my answer. So I'm considering the negative x as another part of quotient, and I would say that negative x should be multiplied by x and negative x should be multiplied by 2. So I do have subtraction, negative x to the power 2 subtracted by 2x itself. These two guys again is going to cancel out each other. I do have negative 3x. I do have, after that, I do have another one that should move it down there. Again, remember, when you have negative 5x subtracted by negative 2x. So negative times negative is going to be positive, and that's why I do have negative 3x. Again, let's do the scenario. So what is the number that I can use it beside x? If I multiply by x itself, I can get rid of negative 3x, and that number is going to be negative 3, right? If I do that one, I do have something like this, and I do have 7. Can I continue? No, because there is no x anymore, so it doesn't matter how many times I keep going. So right now, I just found what is the number that is going to be multiplied by x plus 2, and what would be the remainder itself. I just converted the long, this guy, by using x plus 2 to this one. So I know for a fact that I can convert that one to this kind of terms and the remainder itself. I will talk about it in the future that actually how we can use that in order to draw the function. But right now, maybe some of you would say that it's a little bit long and it doesn't that make much of a sense. Especially when you do have some kind of long polynomials to do that, we could face some problems. We could see some kind of multiplication things, as I just told you about, that maybe it's just negative and we forget about that, blah, blah. So I completely understand it, and let's show you another way or a shortcut that how actually we can do that without having any sweat. So